Alright, so welcome to CAP 6640. So this is the spring semester. It is Natural Language Processing, or Understanding of Natural Language, or Computer Understanding of Natural Language. My name is David Mohaisen. I am a professor of computer science here at UCF. This is my 9th year. For some of you who have taken classes with me before, I usually teach one course each semester, and this is the spring course offering. The point of today's lecture is to go over the syllabus, set the expectations for this course for this session, including the in-person session, and also to have a recording available for those who are taking the V modality. The syllabus overview will cover basic information, course contents, policies, assessments, project topics, classroom etiquette, and then I will be very happy to answer any questions that you might have. By the end of this lecture, you should have a clear understanding of the basic information about this course, including the personnel, meeting times, office hours, means of communication, the overall set of topics we will cover, attendance policies, grading components, and the grade distribution. I will also go over the general policies that you are expected to adhere to, and you will have time to ask questions. So again, this course is about computer understanding of natural language, also known as natural language processing. My name is David Mohaisen. My office is in the Heck building. I do have to run over here, and I am still getting used to how far this building is from Heck. My office is room 207. Since you are here in person, you already know that the in-person meetings are on Tuesdays and Thursdays from noon to 1:15. Office hours will be held for about 45 minutes after the Tuesday class. Historically, my office hours tend to be underutilized. I'm not sure whether that is because I am very efficient in class or because students do not like coming to office hours. Either way, I will start with one office hour slot, and we can adjust as needed as the semester progresses. Office hours will be in person, but I will also open the Zoom link for those who cannot attend physically. The same Zoom link will be used at Mohaisen.me. Email is the preferred method of communication for this course. This is a slight deviation from what I have done in other classes. If you have any issues, please include the course number in the subject line and email me. I typically respond within 48 hours. We are meeting here in room 307. It took me a bit of time to figure out the location as well. Yuan is a PhD student, a second-year PhD student, and he will be our teaching assistant for this course. He will be primarily responsible for grading assignments and may also help with other components such as the project or exam. Assignments account for roughly a quarter of the total course grade. There are no prerequisites for this course. If you are enrolled, you are prepared to be here. There is no required textbook. The course material will consist primarily of the lecture slides and a set of assigned readings. The initial set of topics in this class broadly follows the structure of the course that Chris Manning offered at Stanford, CS 224, a few years ago. Since then, we have deliberately diverged from that offering to make this course more application-heavy rather than theory-heavy as the Stanford version. We will talk about the topics we will cover today, but issues such as ethics, bias, and related concerns will be a subject of significant discussion throughout the course. The projects, assignments, and exams are all newly designed and tailored specifically for this class. I get genuinely annoyed when I see my course materials hosted on sites like Course Hero. So, if you are in this class, please do not do that. When that happens, I end up creating entirely new assignments, and over time I have noticed that assignments tend to become more challenging as I become more familiar with my own content. If you want to think about it positively, think about future students and do not make the course harder for them. Now, let us go over the course contents and modules. The course is organized into 8 modules. The structure is such that we cover 4 modules up to the midterm and 4 modules afterward. The modules are as follows: Foundations of Natural Language Processing, Neural Models for Classification and Prediction, Language Models, Alternative Neural Architectures and Representation Units, Natural Language Generation and Inference, Meaning, Semantics, and Generalization, Large Language Model, and finally, Ethics and Responsible. In total, we will have 24 lectures. Each module consists of 3 lectures, and each module is associated with an assignment. That means each set of 3 lectures leads to 1 assignment. Overall, we will have 6 assignments in this course, similar to the previous version of the course. There is also a small amount of flexibility built into the grading structure, with some bonus opportunities so that students can achieve the grade they are aiming for. You can think of it as having assignments associated with each module, but in practice, there are more or less 2 bonus assignments that you can choose to do if you want. For Module 1, which we will start in the next lecture, we will cover the foundations of natural language processing. This includes the history of NLP, the types of tasks NLP addresses, and the linguistic levels associated with those tasks. We will then move into more recent advances in NLP, focusing roughly on the past 15 years. This includes distributional semantics and word embeddings, with Word2Vec as a concrete example, and we will go into the internal workings of Word2Vec. We will also cover learning and evaluation of word representations, including optimization methods, negative sampling, and issues such as sense ambiguity, where word embeddings do not always work well. Module 2 shifts further into modern approaches, moving from classical statistical language models to neural network-based language models, which form the foundation of today's state-of-the-art systems. Everything we know today about large language models is ultimately built on neural network-based approaches. In this module, we will study neural network classifiers and sequence labeling for NLP, training neural NLP model using techniques such as max margin learning, embedding fine-tuning, and backpropagation. We will also examine syntactic parsing using context-free grammars, dependency structures, and transition-based parsers. Then we move to the third module. As we progress through the course, we will start getting into the more interesting material, essentially building toward an understanding of how large language models, both in general and in more concrete terms. In this module, we will cover language modeling and sequential architectures. We will start with symbolic language models such as n-grams and discuss their limitations, including sparsity problems. From there, we move to neural language models and examine a range of neural architectures, starting with basic feed-forward neural networks and their limitations, then recurrent neural networks and their caveats, followed by SDMs and GRUS and their respective trade-offs. We will also cover attention mechanisms and related ideas. This material culminates in sequence-to-sequence models, which we will discuss in detail around lecture 10. In the fourth module, we will explore alternative neural architectures. We will focus on convolutional neural networks. Although CNNs are commonly associated with vision and image processing, they also have useful applications in natural language processing, particularly for efficient representation. We will discuss their use in phrase, modeling, and sentence-level analysis. We will then move on to more advanced CNN structures and learning from subwords, including subword and character-level representations, which are especially important for tasks like machine translation. After completing Module 4, we will have the midterm exam. The midterm will cover everything up to February 26 and will include material from Modules 1 through 4. After that, in early March, we begin Module 5, which focuses on natural language generation and inference. This is where things become especially interesting. We will cover text generation, summarization, dialogue systems, and the role of reinforcement learning. We will also study conversational question answering and story generation. We will then examine decoding strategies for language models, including how models generate output in practice. While this includes techniques such as greedy decoding, beam search, and sampling, which strongly influence the quality and style of generated text. This concludes Module 5, which I consider one of the most important modules in the course, and one that deserves special attention. Finally, we move into more advanced topics. We will study meaning, discourse, and semantic structures, as well as generalization. This includes topics such as co-reference resolution, semantic composition, and unified and multitask learning. Unified and multitask learning also give us a natural entry point into large language models. You can think of large language models as general-purpose tools that can support many different tasks, such as summarization, generation, labeling, classification, and more. In that sense, LMAs are built on top of the idea of unified multitask learning. From there, we will move directly into large language models, covering their architectures and reasoning capabilities, and then we will wrap up the course with ethics. For those of you who took CAP 5150 with me last semester, you will notice that AI and security raise very similar ethical concerns. In many ways, they are both dual-use technology. We will discuss where AI can benefit from careful consideration, focusing on ethics, bias, and responsible NLP, including issues of dual use, social harm, and possible mitigation. This part tends to be a bit more nuanced and, frankly, more colorful than ethics discussions in cybersecurity. Now let's talk about course assessment, which I know many of you are interested in. The grading breakdown is similar to CAP 5150. Projects account for 28% of the grade, assignments for 24%, attendance for 8%, and exams for 40%, with some bonus. To incentivize engagement, there is also a syllabus quiz, which counts as a small bonus of about 1.3%. Attendance is mandatory for this class. For those taking the virtual version, I want to briefly clarify expectations. Some of you reached out asking for a code to register for the virtual section, and I declined those requests requests. The reason is that you need a valid justification to take the V modality. That was not originally part of my teaching assignment. My assignment this semester is the in-person modality. However, a small number of students who are close to graduation have already accepted job offers, are off campus, and cannot physically make it to the classroom. I did not want to fundamentally alter the structure of the course, so attendance will still be mandated. I decided to open the virtual session only for those cases. If you are on campus, for example, if you are working on campus, then you should come to the classroom. Attendance for students in the in-person modality is mandatory. Attendance for students in the virtual modality is also mandatory, but it will be assessed through a weekly checkpoint quiz. This checkpoint quiz will be open for a short window of time each week. Each week, you will have one such assessment. Attendance is worth 8 points overall, and to receive full credit, you must attend at least 80% of the total number of lectures. For the in-person attendance, I'm going to use a QR code. You're all familiar with how this works at UCF here. It's an application you will need to download on your phone. I'll display the QR code in class, and once you scan it, your attendance will automatically be recorded and graded. If you do not have your phone with you, or if you prefer to install the application later, that is fine. Just send Johan an email indicating that you attended, and starting from the next lecture, we will use the QR code system consistently for everyone. Recordings will not be posted indefinitely. For in-person students, recordings will be available for up to 2 weeks after the lecture. So if you miss a lecture, you can still review what was covered. For students in the virtual modality, recordings will be available for the duration of the semester. Projects, assignments, and exams will be discussed only in class. All work in this course, including projects, must be completed individually. All assignments, quizzes, and exams are individual work. You may discuss ideas with other students, but you must not copy from others. I am stating this explicitly because I have had unfortunate cases in the past, and those situations are not pleasant for anyone involved. All exams will be closed book and closed note. My exam format is as follows. You will take the exam during the full lecture period, 70 minutes on one of the scheduled lecture days. The exam will be similar in style and difficulty to the assignments. You are allowed one handwritten cheat sheet, double-sided. No printed material is allowed. All students, including those with accommodations, must attend the in-person exam session, so please plan accordingly. Yes, exams will be paper-based. I know this is painful for me to grade, but it has proven to be the most effective way to deal with ChatGPT and similar tools. In that sense, we are going a bit old school. This course is about NLP and technologies like ChatGPT, and in your project you will very likely use such tools extensively. However, there are core concepts you must understand and be able to demonstrate independently. The in-person written exam is how I ensure that. Based on my experience teaching last semester, in-person written exams are actually a strong motivator. I taught 3 sections, one in-person, one virtual, and one fully asynchronous. Performance was highest in the in-person section, followed by the virtual section, and lowest in the asynchronous section. This kind of structure helps students do better overall. As for late submissions, this is the same policy I have used for many years. Assignments will be released through the system as modules open. I already have the assignments prepared. I just need to release them as we progress. Eventually, you will have access to all assignments, modules, and materials well ahead of time. All course materials will be released in advance, though not the lecture recordings themselves. The written policy is that assignments are made available well ahead of their due dates, typically at least 96 hours in advance, and they are distributed across the semester to balance workload. You will see this clearly reflected in the schedule. The late submission policy is strict and enforced electronically. If an assignment is submitted late by even 1 second up to 24 hours, a 50% penalty applies. Anything beyond 24 hours receives a 0. Since submissions are handled automatically, there is no practical distinction between being 1 second late or several hours late. You must use your own words in all written work. There are many external resources that cover similar material, but you are expected to demonstrate your own understanding. Simply attending lectures and engaging with the material is sufficient to answer the questions correctly. Do not copy slides or external sources verbatim. All submissions are checked using Turnitin. This semester, the similarity threshold will be strictly enforced. A similarity score above 30% results in a 0 for that assignment, and repeated violations can lead to failing the course. That said, we are not trying to penalize you unfairly. For definitions and common terminology, we automatically ignore matching sequences of 7 words or fewer, which reasonably accommodate standard definition. The likelihood of multiple students independently producing identical sequences of 10 or more words is extremely low. Historically, Historically, the first assignment often shows highest similarity scores simply because students are not yet comfortable paraphrasing. In those cases, the TIA typically provides feedback rather than immediate penalties, and the issue disappears after the first round. This has been consistent across semesters. Your grade will be independent of others' performance, and changes to the syllabus will be rarely done. The grading scale follows the standard structure used in previous offerings, and it begins at 94, an A at 90, the BA at 87, and so on. While BEA may technically satisfy degree requirements, in practice, most students perform well above that threshold. Citations and drawings are something I need to state very explicitly. If I ask you to answer a question and include a drawing as part of the evaluation, you must produce your own drawing. Do not take a snapshot of anything online, my slides, or any external source and submit that as your work. That does not count as effort. If a drawing is required, it should reflect your own understanding. It does not need to be artistic or time-consuming. You can draw directly using a stylus on a tablet, or draw on paper, take a photo, and include it in your submission as a PDF. That is perfectly acceptable. What matters is that the drawing is your own. Drawings are important in this course. If a required drawing is missing or clearly not your own work, I will deduct the full points for that component. I do check them. Most of the drawings we ask for are simple pipelines or architectures such as RNNs, CNNs, or basic processing flows. They are straightforward and meant to demonstrate understanding, not design skill. If your answer relies on material outside the course, you must cite it. Do not cite my slides. I know what is on my slides and I know the sources I use. If you bring in anything external, include a citation. The citation format does not need to be complicated. A list of URLs at the end of the document is sufficient. AI tools are not allowed for writing your answers or results. You will use AI tools later in the course, especially for the project, and I will ask you to include an AI usage statement explaining how you use them. In this course, I expect you to use AI appropriately, but not to generate your written answers or drafts. Requests for special accommodations, except those related to attendance, must go through Student Accessibility Services. Let's now talk about the assessment. Assessment is structured as follows: 24% for assignments, 40% for midterms, 28% for the project, and 8% for attendance. We will have 6 required assignments. Technically, there are 8 assignments total, but only 6 are mandatory. They are spaced roughly every 2 weeks, with a break around spring break. Around early March, just before the first midterm, there will be a bonus assignment. Since you are already preparing for the midterm, I strongly encourage everyone to do it. It is worth 4%, which is significant and can easily shift your final grade by an entire letter. Each assignment covers concepts taught in class. Every assignment consists of 8 questions, each with 2 parts based on 3 lectures. Each assignment is worth 4%. The bonus assignments are pure overflow. They sit on top of the required assignment grade. If you already earned the full 24% from required assignments, the bonus can push you above that, effectively giving you extra credit beyond 100%. Assignments must be submitted as a PDF. Only PDF submissions are allowed. The assignments are entirely written. There are no true or false questions, no multiple choice, and no programming assignments tied to grading. You will answer the questions in your own document, convert it to PDF, and upload it. There are no graded programming assignments. Instead, each module includes a self-guided lab. You complete these labs on your own. I will provide instructions, dependencies, and guidance on what to explore and think about, often using tools like Google Colab. These labs are not graded. They are meant to help you learn and experiment. The project is a major component of the course and will be completed individually. The project topic must be selected from the list provided in the syllabus, which is also included toward the end of the slide deck. The graded project components are structured as follows. The project proposal is due on January 19. That is coming up quickly, roughly 1 week from now. The proposal is worth 3% of your final grade. The project milestone is worth 10% and is due on February 26. The final project report is worth 15% and is due on April 16. If you have questions about these components, ask them now. Now, here's a question about whether students can modify their project halfway. Yes, you do need to submit a proposal at minimum. That is required. You can modify your project after the proposal stage up to the milestone. We try to be as flexible as possible, especially early in the semester. Changes are allowed through the milestone phase. The proposal, milestone, and final report are the 3 required project submissions. The proposal must be exactly 1 page. Fill the page. If there are large unused sections or clearly missing content, points will be deducted. I will personally grade the proposal. I will provide a template for the proposal. Use the template and fill the page. I am not counting words, but you must meaningfully complete the page using the provided format. The proposal should include the project title, why you chose the project, the problem you are trying to address, and the techniques you expect to use. At this stage, expectations are sufficient. You do not need to know exactly what you will use yet. For example, you might say that you plan to use large language models or a particular class of models for a classification or analysis task. That level of detail is appropriate for the proposal. The focus is on motivation, problem definition, and expected direction, not on finalized technical decisions. That covers the proposal. The milestone will be 2 pages, and you will build directly on top of the proposal. You will be working on the same topic, so the problem statement does not change. Content-wise, you expand what you already wrote. The milestone should include a clear problem statement, the techniques you are using, initial results, and a discussion of those results. The final project report will be 6 pages, with unlimited additional pages allowed for appendices and references. The final report must include a concise abstract, a clear introduction, a well-defined problem statement, related work, a description of the techniques used, an evaluation section, a discussion, and a conclusion. You will receive detailed guidance later in the semester on how to structure and write each of these sections. If you have questions about this structure, ask them now. Okay, a question about topic. Can you choose any topic, and how do you know whether your topic is relevant? You do not need to discuss topic approval with me. In the past, I required topic approval, but that turned out to be unnecessarily time-consuming. Instead, I will provide a list of about 20 predefined project topics. You may choose any one of them. In your submission, you must clearly indicate which topic you selected, so I can align your work with the correct expectations. I will also provide a submission template. I will share a minimal example of this template. The template is written in LaTeX. If you are not familiar with LaTeX, do not worry. It is simple to use, and I will post a short tutorial on Canvas. You can use Overleaf, which is supported by the university. You can register using your university email address and access a professional-grade Overleaf account. You do not need collaboration features since this is an individual project, but Overleaf can still be convenient for writing and formatting. That concludes this part. Here is just some more information on the submission. And here too is some more information. To answer your question about what kinds of projects you can do, one category is benchmarking and evaluation. For example, you can evaluate and compare the performance of language models across tasks such as question answering, summarization, or reasoning using standardized benchmarks. This is just a topic category, not a fixed project title. Depending on which benchmark you choose, which models you evaluate, and which tasks you focus on, you can end up with very different projects. Another example is studying prompting techniques such as comparing zero-shot and few-shot prompting and analyzing their effectiveness. Hallucination detection and measurement in language models is another possible topic. Robustness evaluation under linguistic perturbations is also an option. These fall under the broader group of benchmarking and evaluation of NLP systems. Overall, there are 5 groups of topics, and each group contains 4 example topics. The first group is benchmarking and evaluation, which is a very important component of NLP research. The second group is domain-specific language understanding. Code is a good example of a specialized domain. In this category, you could study benchmarking code generation capabilities, automated code repair, semantic code, understanding, or domain adaptation for technical and scientific text. The third group is multimodal and cross-modal NLP, but this is a major branch of the field. Examples include text-to-image generation and control, multimodal reasoning with text and vision, converting natural language into structured representations, and analyzing cross-modal consistency and alignment. The fourth group of topics focuses on security. If you are planning to take my security course, I recommend not choosing from this group since we already cover many of these topics there. Examples include prompt injection attack, LM-based anomaly detection, malware detection using language models, and reliability and uncertainty estimation of language model output. The final group focuses on applications related to bias, ethics, and societal impact. Examples include measuring demographic bias in large language models, studying bias propagation in multilingual NLP systems, ethical boundary testing, and analyzing trade-offs between fairness and performance in NLP models. Some people notice that many of these topics mention large language models. However, not all of them require LMs. For example, bias propagation in multilingual systems or ethical boundary testing does not necessarily require large language models. The association between generation tasks and LMs exists mainly because LMS are currently the most visible and powerful generation model. You can also work with models like BERT or other neural language models, including RNA language models. Generation is not exclusive to LMs too. Another concern is computational resources. Some of these projects may seem to require GPUs or large amounts of memory. You are not required to train or deploy large models locally. If you use language models, you can rely on PI-based access instead of running models on your own hardware. You can also scale your project appropriately so that it does not require significant computational resources or financial costs. Regarding exams, there will be 2 exams in this course. The first exam will take place on March 3rd, which is a Tuesday. The bonus assignment will be due the day before, on March 2nd. The first exam will cover all material up to February 26th. In practice, this includes content associated with assignments up to assignment 3, but conceptually it covers all lecture material through February 26th, including material related to assignment 4. Even if you do not complete that assignment, the material itself is still required for the exam. The second midterm will take place on April 23rd. It will cover material up to April 21st, which corresponds to content through assignment 6, and in some cases up to assignment 8, depending on pacing. The exams are non-cumulative. This means that the second exam will only cover material taught between February 26th and April 21st. There will be no makeup exams except in extreme circumstances. No incompletes will be given in this course, so please plan accordingly. Both exams will be closed book and closed notes. You are allowed one 2-sided cheat sheet, which must be handwritten. This requirement applies to students in both the in-person P and virtual V modalities. Additional details about the exams will be provided later in the semester. Let's now talk about classroom etiquette. Regarding classroom etiquette, please be polite, respectful, and considerate of others. Avoid distractions, arrive on time, and do not be argumentative during class. If you have concerns or questions, raise them respectfully, and they will be addressed. If you need to arrive late or leave early, do so quietly without distracting others. Always adhere to classroom policies and maintain a professional learning environment. Okay, more policies. So, classroom responsibility, non-discrimination policy, religious observances, sexual harassment policies, and special accommodation policy. We talked about the special accommodation policy, and this is here, but everything else we are honoring, so go familiarize yourself with them, see what your rights are, and come demand them. Alright, so this is it. If you have any question, send me an email, and welcome to CAP 6640.